use substitution. Sometimes there are some integrals that we cannot integrate directly. We have to do a substitution before we can integrate them directly. For example, the integral of x squared plus 1 all to the power 1 over 2 x dx. We can't expand this so that we can integrate directly. But what we can do is to do a substitution. So if you let u to be equal to x squared plus 1, this value over here, this function over here, then realize that if you differentiate u with respect to x, we are going to get 2x. So you can see that x dx is in the integral over here, so we can make x dx the subject. So x dx, we divide both sides by 2, will be equal to 1 over 2 du. Substitute whatever is here into this. So we are going to get something like this. Whatever we see x squared plus 1, we put u. So our integral becomes u to the power 1 over 2. U to the power 1 over 2. Then times 1 over 2 du. So this is the same as 1 over 2 times the integral of u to the power 1 over 2 du. So you can see that this has now become a direct integration. So we have 1 over 2, we add 1 to the exponent, which will give us 3 over 2. Then we divide by the result, which is 3 over 2. Plus the constant of integration, c. Now we simplify this to obtain 1 over 3 u to the power 3 over 2 plus c. But we know that the u is equal to x squared plus 1. So you get x squared plus 1 to the power 3 over 2 plus c. So that is how the u substitution works. Then the trapezoidal rule. Now if you have this curve f of x over here, and you want to find the area under the curve, you can use trapezium to approximate the area under this curve. We draw a trapezium over here, to approximate the area of the curve. So the trapezoidal rule says that if you want to find the area from A to B, in this case from x0 to x sub n, it is given by h over 2 times f of x0 plus f of xn, the last one, then plus 2 times the values, the ordinates. We call this the ordinates. Twice the ordinate, twice the sum of the ordinates between the last value and the first value. That is the first ordinate and the last ordinate. And the h here is the height of the trapezium. Now the h is found using b minus a over n. So the n is the number of sub-intervals. So in this case we have 1, 2, 3, 4 sub-intervals over here. So if you have 5x values, you are going to get 4 sub-intervals. If you have 6 x values, we are going to get 5 sub-intervals, and so on and so forth. Now let's take an example. Using the trapezium rule with ordinates s equal 1, 2, 3, 4, and 5. That is with ordinates at s equal 1, 2, 3, 4, and 5. So we have 5 s values. So we are going to get 4 sub-intervals. Calculate correct to 2 decimal places the value of this. So we know that we can form table of values for this. You know, f of s is equal to x plus 2 over s squared. So f of 1, this one over here, we're going to find the ordinates that correspond to all this, because that is what is in the formula. Will be equal to 1 plus 2 over 1 squared, and this will give us 3.00. So we repeat this process to find all the ordinates, and we should get something like this. Now, using the formula, you know, the trapezoidal rule said that the area from 1 to 5, or from A to B, from 1 to 5, will be of f of x, which is x plus 2 over s squared, the x will be equal to h over 2. So the h is given by b minus a, which is 5 minus 4 over n. So we said the n is 4. The n is 4, which is equal to 1. 5 minus 1 rather. 5 minus 1, this will give us 4. So it's approximately equal to h, which is 1, over 2, then times the first ordinate plus the last ordinate. So 3.00 plus the last ordinate, which is 5.00, 5.080, then plus 2 times the remaining ordinates, plus 2 times the bracket 2.5, 2.500, then plus 3.22, 3.222, then plus 4.125. Now if you take the calculator and evaluate this, you are going to get 13.89 correct to 2 decimal places. So that is how the trapezoidal rule works. We can also use the direct rules to perform the differentiation or integration of trig functions. So if you have, let's say, y equal sine x, the derivative of sine x dy dx is equal to cos x, Then if you have y equal cos x, the derivative, that is dy dx, is equal to negative sine x. We have y equal tan x. If you have y equal tan x, the derivative is dy dx is equal to sec square x. Sec square x. Now the integral of cos x, it means what did we differentiate to get cos x? So integral of cos x, integral of cos x is equal to sin x plus c. Sin x plus c. But that was what we differentiated to get cos x. Now the integral of sin x, it means what did we differentiate to get sin x? We didn't differentiate anything to get sin x. The only thing we differentiated to get something similar to sin x is cos x. So it is negative of this. So then we have integral of negative of sin x. So if you divide through by the negative, it will affect the result, which is negative cos x. So if you integrate sin x, we get negative cos x plus c. Now if you integrate sec square x, you know already, it means what? So sec square x dx, it means what did we differentiate to get sec square x? And that is tan x plus c as the constant of integration. So in short, we use these techniques: the use substitution, the trapezoidal rule in some cases, and the trig functions. We use this to integrate some of the functions that cannot be integrated using the direct integration rule.